Okay, good morning, everybody, and welcome to our Pre-Calculus 40S class. Today, what we're going to do is we're going to start our Chapter 6, Part B, or Part 2. So, in this particular chapter, or in this particular part, we are going to be focusing on graphing the functions. And you will find that all of the things that we learned in Chapter 6, Part 1 will be become useful for this one. So just to kind of talk about this before we get into this one here, I want to say that this topic is going to be a very, very short one. So it's probably going to take us about a week to finish everything off. And that, it's just because it's pretty short. Okay. So um, here's what we're going to start off with. We're going to start with the key terms or vocabulary just because that we're going to use that later on as we go on. So when we talk about graphing a trigonometric function, we're going to focus on sine and cosine functions. We're going to find that these are called periodic function. Periodic. I'm going to start with the word periodic function and then define what that is. So periodic function is a function that repeats itself over a regular cycle or intervals of its domain. So that's what periodic function is. So it repeats over and over and over and over again. Now, under that periodic function is a sinusoidal function. I want to put something in here, like I'll do an example. Example would be your heartbeat. So when you every time your heart beats, it's basically a contraction, relaxing of your heart muscles. And you can go and take a look at the ECG graph. It's electrocardiogram graph. So it's just basically repeats over and over again because that's how your heart does its function. It constantly repeats contraction, relaxing. Okay. But very specifically is a sinusoidal function. So a sinusoidal function is the same thing as a periodic function. Okay. Is a function, a smooth curve, and I had to write down the word smooth or include the word smooth, that fluctuates back and forth like a sine graph, which we will talk about today, and a curve. This is a curve that oscillates repeated up and down from the center line. That's our main topic for today, the sinusoidal function. What does that look like? We will talk about that. Now, another thing that I just want to define first, because we're going to see it over and over again when we talk about the graph, is the word amplitude. Now, if you've taken a physics class, okay, so in physics class, you talk about waves, different kinds of waves. And you would talk about amplitude. So what is an amplitude? So amplitude is the height from the center line, okay, also called or median line, okay, to the maximum or to the minimum, okay. um and I'm just gonna do a graph in here that we will see. This is a graph that we're going to talk about, the sinusoidal graph. It's a wave. So when you think of a wave, it goes up and down, right? And it's a smooth curve. Okay. So amplitude is here's a middle line, or center line, whichever you call it. Okay. We will call it median line. This is your amplitude from median line to the highest maximum. Okay, so this is amplitude from median line to maximum, or from median line to minimum. And here's a minimum, the lowest point. So this is also called amplitude. So two ways you can look at that, from median to max or from median to minimum. Now, if you have a maximum and minimum, a way to calculate that, I'll just write it down. Amplitude is equals to max minus min. So that will give us the height from maximum to min, and then dividing it by 2. So this one we will talk about later on when we're talking about properties of sinusoidal functions. Okay, so we figured out what amplitude is. Now let's talk about period. What is a period? So the period is how far is the maximum to the next maximum. Okay, so we're looking for the period is basically how far is the first maximum to the next maximum. Okay, or first maximum to the second maximum, or from a minimum to the next minimum. Okay, so what's happening here, the word period is basically how long does it take for one complete cycle. Okay, so another thing that you can think about is how long it takes for one complete cycle. Okay, so that's what period is. So if we have a graph, because we're going to do a lot of graphs in this particular topic. Okay, so here's our function. Okay, here's our graph. I'm just going to, period is from here to there. So how long is that? Okay, so from a maximum to the next maximum, we're looking for how long that is. And then, or we can go from minimum to the next minimum. That's also a period. Okay. The next one is phase shift. Phase shift is how far a function is shifted horizontally, how far the function is shifted horizontally from its usual position. Okay, so phase shift, we actually kind of talked about the word phase shift. We didn't say phase shift when we talk about translation. So another thing that you can think of there is i.e. it's a horizontal translation. Okay, so when we talked about the transformation of graph, we're going to talk about phase shift. There's also a vertical shift, which we will talk about later on too when we do more. So I want to touch on these vocabulary first because we will see it in our examples. Now, before we get into that, I just want to take a look at this one here. This is something that we've already talked about before. This is a unit circle, and this is going to be super, super handy when we talk about the graphing. So for a given angle, like for example, this angle right here, it's pi by 6. We have x and y coordinates of that particular point in a unit circle. The x coordinate is this is the x, and then this is the y. The x is equal to the cos of the angle, cos of theta. And then the y is equals to the sine of theta. We will see that again over and over again. So let's go ahead and take a look at this one. So our main purpose for today is to just see what the graph would look like. The graph of y equals sine of x and y equals to the cosine of x are called sinusoidal functions. Sinusoidal function, we define what that is. Okay, it's a smooth curve that fluctuates up and down. So a sinusoidal function have a maximum and a minimum value that are same distance from the center line or midline from the graph. So we will sketch the function of y equals the sine of x using the table of values over the domain of 0 to 2 pi. So we're limiting our domain from 0 to 2 pi. Okay. This particular case in here, I'm just going to have a circle here going. So y equals the sine of x. So remember, sine of x is the y coordinate or y value in the unit circle. Okay, so y value in the unit circle. So I'll just do a unit circle up here. Kind of always reminds us. Okay. So here, this is going to be 0 radian. 0 radian. This one here is pi halves radian. Pi divided by 2. This part here is pi. All the way here, this is 3 pi halves. And then going back here is going to be 2 pi. So we've done the complete circle. So let's go ahead and try that. Now, in this particular case, we are just using sine of x, or we're graphing sine of x. I'm going to start with these angles in here, 0, pi halves, pi, 3 pi halves, and 2 pi. And then looking at the values for those, because those ones are easier to figure out. Okay, so here at 0 radian, the coordinate is 0, 0, right? So 0 radian, the coordinate is 0, 0. So we're looking for the sign. The sign would be the the sign would be the y value of the coordinate. So this is going to be 0. So this is going to be 0 over here. Okay. Up here, what's the y value? The y value for pi halves is 1 because it's up above. So 1. Over here, when you go to the pi, the y value is 0. The y value is 0. And then when we go here at 3 pi halves, the y value is, because it's below, so it's going to be -1. So 3 pi halves is -1. And then if you go back up here at 2 pi, we're back at 0 again. So it's going to be 0, okay, 0, 1, 0, -1, 0. So it's going to fluctuate like that. Now we could figure out the rest of these values. Okay, so these ones are the key ones that we could do. Now where's pi over 6? Well, pi over 6 is right here. Okay, so how far is that? How far up is that? What's the y value? So that one at pi over 6, that's the 1/2. Okay, so 1/2 right there. So 1/2. If this is 1 unit circle, right? Then this one here is halfway up there. Pi over 4. Where's pi over 4? Would be right there. Well, how far is that one? That's our √2 over 2. So √2 over 2. Pi over 3. Pi over 3. So pi over 3, that's going to be up here. So how far up is that? Remember, it's always the y value that we want. That's going to be √3 over 2. And then at pi halves, we know it's up again. Okay, now you go here, here, and here. So these angles here are these angles on our unit circle. So it's going to repeat itself. Now, after that pi halves, the y values will start to go down to 0 again. So here, the y value, remember, it's always the y value that we want. So that one is going to be the same height as this point here, which is √3 over 2. Okay, and then you keep going. This is going to keep going down. So what's that one? That's the same y value as this point over here at pi over 4. So that's going to be √2 over 2. And then this one here, 5 pi by 6, which is this a reflection of this one. So same height as that one. So that's going to be 1/2. Now you'll see that here, the sine of x, okay, sine of x is basically the y values, okay. Our x is the angle in radian. So 0, it's going to go up, 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 hit the maximum at 1. And then once it hits a maximum of 1, it's going to start to go down, 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 down. It goes down here at 0. And then what's going to happen? After this pi radian, the y values would be below the x-axis. So that means it's going to be a negative value. So what's going to be the negative value? That's going to be the same reference angle as this one. So that's going to be a negative 1/2. So this is going to be the same one, but this is going to be a negative. And this one here, it's going to be below. So that's going to be negative √2/2. And then this one here is going to be √3/2. And then when we get into this one here, 3 pi/2, the y value is -1 because we're at the very, very lowest. And then it's going to, as you can see, it's going to start to go back up again. So this particular case is y there. So this is still going to be in the negative. So it's going to be, oops, this one should be negative. Should negative √3/2. And then this is going to be negative √2/2. And then negative 1/2. Negative 1/2 right there. And then 0. So this particular case, these are the things that we learned in chapter 6, first half of chapter 6. So what does that mean? So this is 0, this is 1/2, that's easy to graph. Well, what's √2/2? √2/2 is about 0.7. So positive 0.7. What's √3/2? Well, that's going to be approximately 0.866, 0.86 or 867 if you want to round it off to 2 decimal places. And it's 1. And then this is going to be 0.87 again, 0.7, and then 1/2. That's going to be negative 1/2. So negative 0.5. That's going to be negative 0.7, negative 0.87, negative 0.87, negative 0.7, and then negative 1/2. So we're going to graph all these in here and see what that graph looks like. And I kind of spoiled the surprise at the beginning because I already said what that one would look like. So let's graph this one here, 0, 0. So the x is the angle. The y is equals to the sine of x, which is the 0. So 0, 0 is right there. I'm going to graph these ones first. Okay, I'm going to graph these ones. These are the quadrantal angles because that's right on the quadrants. So 0, 0, and then at pi halves, well, where is pi halves? So from here to here is pi. Pi half is the middle of that. So the pi halves is right there. It's a fraction. So pi halves, it says, at pi halves, it says it's 1. Right there. Okay, now let's keep going. Pi, if x is pi, then sine of pi is 0. 0. And then let's go 3 pi halves. So if this is 1/2, this is going to be 2 halves. Then this is going to be the 3 pi halves. 3 pi halves is going to be at -1. -1. And then 2 pi, it's going to be here. So the graph would look like this. It would be a smooth curve. So it increases and then reaches the maximum height at pi halves and then decreases back down to 0 and then decreases some more back down to -1. And then after that, it's going to increase right back at 0. Okay, so Let's see where pi by 6 is. Well, where's pi by 6? If you look at this one over here, there's 1, 2, 3, 4, 5, 6. This is pi, and pi by 6 is 1/6 of a pi. So this is going to be a half right there. Okay, 5 by 6. So this one here is, if this is whole thing is 6, pi. And then this one is going to be pi by 6, 1/6, 2/6, 3/6, 4/6, 5/6. 5 pi by 6 is 1/2, so it's right there. And then 7 pi by 6, right here, it's going to be negative 1/2. Negative 1/2 would be right there. And then 11 pi by 6. So every part here is pi by 6. So 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6. 11/6 is negative 1/2. So the graph is going to go like this. Okay, remember it's a smooth curve. Okay, so that's the increase up there. Okay, so increasing to the maximum and then decreasing up to pi. So that's this part of the graph. Okay, this part of the graph is basically we're going from here, reaching its maximum, and then falling back down to 0. Okay, so that's that part, the top. And then from here is the one in the quadrant 3 and 4. Okay, so when we did the cast method, right, cast, right, where is sign positive? Where is sign positive? Means above the zero line. Positive in here, in quadrant 1 and 2, so between 0 and pi. So it's positive between 0 and pi. And where is the sign negative? The sign is negative here in quadrants 3 and 4, between pi and 2 pi. Between pi and 2 pi. Okay, so that's basically what the graph looks like. Okay, it's a smooth curve and it reaches its maximum and it falls back down. It will repeat over and over again, but in our case, we're only doing from 0 to 2 pi. So now what we're going to do is we're going to write down some characteristics. So some characteristics of this particular graph. So what is the maximum value? That means what's the highest value? The highest value, max, is equals to 1. That's the highest it can go. What is the minimum value? Minimum value is the lowest one it can go. So that's going to be a negative 1. What's the amplitude? Okay, amplitude is the distance from middle to the maximum. Well, how far is from middle to maximum? That's going to be 1 unit. Okay, so amplitude, we talked about that. We defined what amplitude is. So amplitude is from the middle line to the maximum or middle line to the minimum. Period. What's the period? How long does it take for it to repeat itself? Now this cycle repeats itself every 2 pi. So period is equals to 2 pi. Okay, as you can see, we are back to where we are after we've turned 2 pi radians. So this is 0, turned, okay? So if you go here, we're not back to where we were. The complete cycle is that one right there, 2 pi. What is the y-intercept? Y-intercept is 0, okay, where that crosses the y-axis. This is the y-axis at 0. X-intercepts. Interesting in this particular case that there could be lots or infinitely many x-intercepts. But because of our given domain from 0 to 2 pi, how many x-intercepts do we have? We have x-intercept here at 0, 0 radians. We have also an x-intercept here at pi radians, pi radians. You can put r there, radians, but if we use the pi, it's already understood it's in radian mode, so we don't have to do that. But if you want, you can put that down still. And then this is the other x-intercept, it's 2 pi. Now you'll probably see what's going on in here. It's going to be 0, pi, 2 pi. Sorry, you can't see that. You might see the pattern. 0, pi, 2 pi. If we continue on with this graph, continue this sinusoidal function, we're going to have a lot of x-intercepts. The next one would be 3 pi, and then 4 pi, and then 5 pi, and so on. Okay, but we're limiting our domain, so from 0 to 2 pi. So domain here is from 0 to 2 pi, including those two. Or we can say from x is greater than or equal to 0 or less than or equal to 2 pi. So either one is perfectly fine, but get used to both. Range are the possible y values. So this graph fluctuates between -1 minimum to a maximum of +1. So we can say y is greater than or equal to -1, but less than or equal to +1. Okay, so that's our first graph, trigonometric sine graph. Now we're going to take a look at the next one. Okay. So in this particular case, we will sketch the function y equals to cos of x. We're going to start with the table of values again and then we're going to graph the function from 0 to 2 pi. So what does a cos function again? So the cos function is in terms of a unit circle, we're looking at the x values, x coordinate. So x values or x coordinate on our unit circle. Okay, circle. So I'm just going to take a look at the unit circle. Just write it down over here. I'm going to start with the quadrantal angles. So this is going to be 0, pi halves, pi, 3 pi halves, and then all the way back here, that's going to be 2 pi radians. Okay, so because we're looking for the x values or x coordinate here, this is at center 0, 0, the origin. So this one at 0 degrees, okay, at 0 degrees, the x coordinate of that is 1. So 1. Okay, I'm going to go over here at pi half. So pi half, what's the x coordinate for that one? This is going to be 0. So pi halves is 0. Now over here at pi radians, the x coordinate is, we're at the -1. -1. then go back rotating this way, 3 pi halves. So this is the 3 pi halves. So we are at, what's the x coordinate there? It's 0. And then going back to this one in here, what's the x coordinate there? It's going to be 1. So in this particular case, we start at 1 and then, okay, we start at 1 in here. And then we go, well, pi over 6. Well, pi over 6 is right here. Okay. Because we're talking about the coast, we want the horizontal distance, the x coordinate of that particular point there, which is, okay, that one is root 3 over 2. It's a positive because it's on the positive side. Now, what about pi over 4? Pi over 4 is right there. Now, what is the x coordinate of that? So x coordinate would be root 2 over 2. And then we go pi over 3. Where's pi over 3? Right there. Pi over 3 is up there in quadrant 1. What's the x coordinate there? That would be the 1/2. Okay, so we've listed the values there. And then of course root 3 over 2, that's going to be 0.866, so 8.87 approximately. Root 2 over 2 is approximately 0.7, and then 1/2 would be just a half, 0.5. Now we're going to go to the other side here, and we're operating in quadrant number 2. So 2 pi over 3, which is over here, that one is going, okay, remember, it's the x-axis that we want, or the x coordinate that we want. So it's going to be on the left side, so that's going to be a negative 1/2. Okay, now you're probably going to see, hey, these two are kind of mirror image, but it's flipped onto the other side, so it's going to be negative 1/2. And then the 3 pi over 4, which is this one right there. Okay, remember we want the x coordinate. Okay, so that's going to be root 2 over 2. So, but it's on the left side, so it's a negative root 2 over 2. And then this part here is going to be at 0.8. 0.8. So negative root 3 over 2. So it's a reflection onto the y-axis there. Keep going to this side. Okay, so these ones here, this one is 7 pi by 6. It's going to be negative root 3 over 2. Okay, because it's going to be the x coordinate of that point. And because it's the x coordinate, it's on the left side, so it's a negative. And then this one here, this one is 5 pi by 4. So that's going to be a negative as well. So negative root 2 over 2. And then here, negative 1/2. Yeah. My circle is not a perfect circle, so it doesn't, even though it's doesn't look like a half, negative a half. And then we go here. This one here is, because we are operating in quadrant number 4, quadrant 4 here, the x at 5 pi by 3, that's going to be positive 1/2. And then 7 pi by 4, that's going to be positive root 2 over 2. And then finally, positive root 3 over 2. And then 2 pi, it's going to be back to 1. Okay, so what's happening in here, I'm just going to write down the cast here. We're looking for, where is cosine positive? Where is cos positive? So here, C-A-S-T, that's a cast. It's an acronym. It's a way for us to remember what's positive. So cosine is positive in quadrant 1 and quadrant 4. So let's see. Cosine is positive in quadrant 1. Quadrant 1, so that's between 0 and pi halves. Okay, so all of these are positive between 0 and pi halves. And then in quadrant 4 is between 3 pi halves and 2 pi. 3 pi halves and 2 pi, these are all positive. And then over here, between pi halves to 3 pi halves, these are negative values. So everything is kind of falling into place and everything is connecting in here. I hope it's connecting for you. So now that we have all these parts, I'm just going to graph some special parts here, special points. And then the rest we could discuss and see what that actually looks like. Okay. I have to remember cosine is how far along the x is the point, the terminal point. So if I turn 0 degrees, which I'm not turning anything at all, my x is 1. I'm starting my point right there, 0, 1. And then my next one at pi halves is 0. Well, where is pi halves in this one here? If this is from here to here is pi halves is half of that. So pi halves is right there. So pi halves is at 0, right there. And then at pi is negative 1. Pi radians is negative 1. Okay. And then 3 pi halves. So 3 pi halves would be here. How do I know that this is 3 pi halves? This is 1 half, 2 halves, which is pi, 3 halves, 4 halves, and 4 halves is 2 pi. So 3 pi halves is 0, and then 2 pi is back at 1. Okay, so what does the graph look like there? This is a periodic function. It's going to be a smooth curve. Okay, it's not a V. It's going to be a smooth curve. So it's going to look like that. Okay, so it starts off like that. So this is, yeah, like that. And then from there, it's going to be a smooth curve. It's going like this. Not quite happy with that one. Okay, so here's my graph here. Okay, so it's a smooth curve. Okay, so there's a curve in here, and then there's like a curve in here. That's the third part, and then that's the fourth part. Okay, so in this particular case, because we're talking about cosine graph, we're talking about the x values of the coordinate points on a unit circle. So now let's take a look at this one again. Some characteristics of that. What is the maximum value? So maximum value is the highest value. So max is equals to 1. Minimum is -1 because that's the lowest value. Amplitude, that's the distance from middle line to the highest or middle line to the lowest. So amplitude is going to be 1. Period, how long does it take to repeat itself? And the way we defined it is how long is from a maximum to the next maximum. So when this one is actually really, really clear. How long does it take from one maximum to the next maximum? That's 2 pi. From 0 to 2 pi is 2 pi. Y-intercept here is at 1. X-intercept in this particular case, and I will talk about that in a second. X-intercept is where the graph crosses the x-axis. We've known that for quite some time. In this particular case, there are two x-intercept is pi half, 1 pi halves, and then 3 pi halves. So pi halves and 3 pi halves. Though we only have two x-intercepts here because our domain is limited from 0 to 2 pi. If we were to continue this graph over and over and over again, we'll see that the x-intercept is going to be infinitely many. So you might see the pattern going on in here. This is 1 pi halves, 3 pi halves, then the next one would be, see here, 1, 3. The next one would be 5 pi halves, 7 pi halves, and so on. Okay, so you will probably see the pattern as we go on. Domain. So what's the domain? Because we're limiting our domain from 0 to 2 pi, so we can write it 0 to 2 pi, or we can write that as an set notation. X is greater than or equal to 0, but less than or equal to 2 pi. Range, we can do it as interval notations from -1 to +1, and or set notation is y is greater than or equal to -1, but less than or equal to +1. Okay, so we've kind of thoroughly talked about that one in this particular case. We're going to move on to the next one, next page. So now what we're going to do is we're going to look at characteristics of y equals the sine of x. We're going to just look at this in the domain using the domain from 0 to 2 pi as shown below. Okay, so if we are just given this graph, what are the characteristics? It says here, notice the 5 key points. So 5 key points in terms of sine of x for y equals the sine of x. So sine of x always starts at 0, 0. So this is the very basic sine graph. It starts at 0, 0. And then the next one, okay, 0. Next one would be pi halves at 1, pi at 0, 3 pi halves at -1, and 2 pi is 0. Okay. So these are the 5 key points. Sometimes what I try to do here is that when I have to start off with y equals the sine of x, I know that it starts at the 0, 0 level. Okay, so the 5 key points are coming from the quadrantal angles. So 0, pi half, pi, 3 pi halves, and then back to 2 pi. So all these key points are the quadrantal angles. So 0 and then 2 pi for sure after we go around. Pi halves, pi, 3 pi halves. Oops, 3 pi halves. And then back to 2 pi. Okay, so, and then the rest, you can just outline them. Okay, so here, just by looking at this graph, and then we're actually going to cross this off because we want to just go from 0 to 2 pi. So let's cross this part off. So characteristics. So what is the y-intercept of this graph? So the y-intercept of this graph is at 0. What is the x-intercept of this graph? It's going to be from 3 of them, right? It's going to be at 0, pi, and 2 pi. Okay. What's the domain? Domain is from 0 to 2 pi. Domain is from 0 to 2 pi. Or we can say x is greater than or equal to 0, but less than or equal to 2 pi. Range. Range is from -1 to +1. Range are the possible values. Okay, so the graph are limited between -1 to +1. -1 to +1. If this continues on, it's going to hit the maximum still at 1 back. Okay. So -1 to +1. Or we can say y is greater than or equal to -1, but less than or equal to +1. Amplitude. Amplitude is from median line. So where's the middle? So if this is the graph, maximum, minimum, the middle is right in between. This is a middle line. Median line. Okay, or midline. Median. So the amplitude is how far is from here to there, right? So from median line to the maximum, amplitude is 1. Amplitude is 1. So I'll just put A is equals to 1. Period. Period is how long does it take to repeat itself. As we can see here, it's going to repeat itself every 2 pi. We don't see it here. But if we, oh yeah, when we talk about the period, how long is it for it to repeat itself? We said the period could be from a maximum to the next maximum, minimum to the next minimum. The other possibility is from the first starting point to the next starting point. So that's going to be 2 pi. Period is equals to 2 pi. And then maximum value, maximum is equals to 1. And then minimum value is going to be -1. Okay. So looking at this one here, we can actually see that we can easily graph our sine function, looking at, this is what you're visualizing. This is what you're visualizing. This is what you're thinking about. The unit circle. And how is it unit circle? Sine are the y values on the points in unit circle. So looking at these ones. Okay. Okay, we're just going to do the last page here on page 7. We're going to look at characteristics of cosine x. So here, cosine are the x coordinates on unit circle. Okay, so that's what we're thinking about. So what are the key points in here? There are 5 key points. it's going to be 0, 0 is at 1. Pi halves is going to be at 0. Pi is going to be at -1. 3 pi halves is equals to 0. And then 2 pi is back at 1. Okay. So how do I remember this? Okay. This is what works for me, is I'm visualizing a unit circle. We've seen unit circle so many times last unit. You can see what that one looks like. Unit circle. And these 5 key points for y equals to cosine of x. So x are the angles, and then cosine of x, that would be the x coordinate of the point on the unit circle. So this is going to be 0 radian. This is my pi halves, pi, 3 pi halves, and then when I go back all the way around, I'm back to 2 pi. So because it's a cosine, I'm looking at the x coordinate. So from here, this is my 0 degree, this is 0 radian rather. So 0 radian, I'm at x equals to 1. Here at pi halves, my x is 0 because this is going to be 0, 1. Pi radians, I'm on the left side, so it's -1. And then 3 pi halves, I am at 0, okay, because I'm not on the left and not on the right, it's just 0. And then back here at 2 pi, I'm back at x being 1. So these are the key points that drives these things, right? Key points. Okay, so another thing that I think about this is like, I know that in the cosine, you're starting with the maximum, going to the next maximum, starting with the maximum, going to the next maximum, and in the middle is the minimum. And then in between that is going to be the median. Okay. I should have talked about that in the other one too. I'll go back. Okay, so what are the characteristics? Characteristics, y-intercept, in this case, y-intercept is equals to 1. X-intercepts, there are actually 2. So x-intercepts are pi halves and 3 pi halves. Domain is limited from 0 to 2 pi, so 0 to 2 pi, or we can say x is greater than or equal to 0, but less than or equal to 2 pi. Range will fluctuate between -1 to +1. So same thing as the sine function, or y is greater than or equal to -1, but less than or equal to 1. Amplitude is from median to the maximum. How far is that? So that's a equals to 1. Period is how long does the cycle repeats itself. It repeats itself every 2 pi radians. Maximum, max is equal to 1. Minimum is -1. Okay. So just to kind of review this part here. So when we're looking at the cosine, we're going to start with maximum to maximum. And then in the middle of the maximum is a minimum. And then in the middle would be the 0. I'm going to go back to sine because I didn't talk about that. Sine, we're starting at 0. 0 and ending at 0. In the middle is 0. and then the first one would be maximum and then minimum. So there you have it. We're not going to assign any homework here, but if you are interested, just your assignment would be to just read the next few pages of our notes of our book, if you want. So just read what says on the book on page. Okay. So if you want, you can just read page 510, which is basically something that we've done. We will do the tangent of x later on as well. So if you want, you can read that. Just read ahead. And or if you want, just keep going with reading on 6.5 and if you have time right now. Okay, so this particular unit is super fast, like it's pretty thin. So I'm gonna leave that with you and just gonna read through it if you have time. If you don't have time to do any work, then just focus on getting your test completed. Okay, if you haven't finished the test yet. So there you have it, and thank you very much for the people who are watching the video. And I just want to say that I'm looking at the time. June 12th. Okay, I'm just gonna write that down. Information. So starting on June 12th. That's our last, supposed to be last lecture day, last day of classes. Okay, so it's gonna come super fast. We need to finish up the chapter 6 part B or part 2. We need to finish up the chapter 7 more trigonometry part, and then we're gonna do chapter 8. So it's gonna be a super quick time. So I encourage you to keep at it, do as much as you can. We're on the sprint right now, getting to the finish line. So get as much stuff done because it's June 12th is going to come real soon because right now it's May 20th. So there you have it. Last day of classes is June 12th, which is kind of nice to think about, but it's kind of nerve-wracking because it's going to come by super fast and we're going to be done and we have so much things to do still. So anyways, like I said, thank you very much for watching the show. Like always, if you have any questions, any concerns, always talk to me, email me, and well, hopefully I can answer your question and solve whatever issues that you have or concerns. Yeah, and hopefully in a timely manner for sure. Okay, so thank you, and I'll leave that with you, and have a great rest of your day, everybody. Thank you for watching. Bye for now. 123 days.